Hi everyone, welcome back. Okay, so here is the definition of Poisson's ratio. I know I mentioned it earlier in the video, and I think I actually mixed up the subscript, so go with this, not with what I wrote in the video. Big thing here is to remember is that Poisson's ratio is simply telling us that our strains are connected. If something gets longer, well, it's going to get thinner. If something gets shorter, it is going to get fatter. Because the material has to go somewhere. And that's going to be connected. Now, Poisson's ratio is dimensionless, and there's a kind of a rule of thumb here that it's never going to be more than 0.5 usually, or less than 0.15. Okay, if you see something at 0.5, it is usually very, very flexible. It'll be something like rubber, and as you get lower and lower, it might be more like a ceramic. But don't forget this. Another thing we talked about was the shear modulus. Now, I just mentioned that it was the shear modulus. I didn't say where it came from. But just like we have that, stress-strain diagram for normal stress and normal strain, that's when we're just stretching something by tensile force, we also have a shear stress versus shear strain diagram. And similarly, the amount of stress it takes to change a certain amount of strain, that slope is going to be our shear modulus, G. Now, just like with our elastic region for modulasticity, this only works in the elastic region for my shear stress versus shear strain diagram. Another thing is something called the bulk modulus K. Bulk modulus K, which if we are under hydrostatic pressure, then we can see how much it's going to change the change in volume over our total volume. Because hydrostatic pressure is from all directions at once. Okay, and all these things are connected. So if you have one, you can calculate the rest. So if I have my modulus elasticity and Poisson's ratio, I can calculate both the shear modulus and the bulk modulus. That can be very, very helpful in your problems, so make sure you don't forget this. There's a lot of equations in this chapter, but most of them are fairly simple to implement, as we're going to see. So don't forget too much, just write them all down, write what the variables mean, and we'll get through this. Thanks for listening. I'll see you later. Bye-bye.